Okay, this is the Math at Work 10 lesson on calculating the area of 2D composite shapes. Alright, so in this lesson we're going to be expanding on our knowledge of just calculating area of general two-dimensional shapes and looking at calculating the area of composite shapes. Okay, so when we talk about a composite shape, we're talking about shapes that are still again two-dimensional but are kind of a combination of at least two other shapes, right? So as you can kind of see in these examples, right, you have a combination of, some rectangles and then a triangle, or here you seem to have a triangle with a bit of a rectangle and maybe a half of a circle cut out, and then here you kind of have a square with these two semicircles attached, right? So again, the shapes that we'll be dealing with are still just going to be circles, squares, rectangles, and triangles, but just a combination of them, and just needing to kind of be really careful with how you cut up your shape, right, to find the area. So there's not really a whole lot of other background key terms or anything other than just what a composite shape means. It just means composed of two or at least two things, so two or more, and then we're just going to look straight into examples. Okay. So in this first example, Felicity recently moved into a new house. She plans to install a hardwood floor in her dining room and her living room. Below is the sketch of the area. Calculate the area of the floor to be covered in hardwood. Right? So as we go through these, a little bit trickier for me to kind of do these. It might take a little bit of time to get the diagrams in, but let's kind of work through this, right? So with question 1, okay, the shape that we have looks something like this, right? With the following dimensions, there was 12 feet up here, this was 18 feet overall down the bottom, this was 24 feet, this was 12 feet, this was 6 feet, and then this was 12 feet along here, right? And these were all right angles, indicating that what we have are in fact rectangles. Okay, so there's always a couple different ways that you can, break apart these types of shapes. So for instance, one person might cut this shape down the middle this way, right? And look at it as, well, I'm going to calculate the area of this square and this rectangle. Someone else might look at it instead and cut it this way, right? And look at this large rectangle and this small rectangle. It really doesn't matter how you approach this, just as long as you're kind of laying out your work, okay? I probably would have done it in the same way in the first one, just because that's how it was also split up in terms of which rooms, right? And then I just kind of label it, say, okay, well, this is room number 1, area number 1, and area number 2, okay? So since they're both rectangles, all I would need to do here is look at, okay, well, the area for 1, it's actually a square here, where it would be the base, right, which, well, it's not the 24, but this value here was 12 that it would have cut off, so if it's 12 here, it's 12 down here as well. So our area would have been found by taking our 12 feet, right, and then multiplying it by our 12 feet here. Right, so the area there is 144 square feet for that room. And then we would looking at the second area. Okay, so again, this is a larger rectangle. So again, the area would have been calculated by doing length times width, or base times height. The base along here, right, again, would match with what's here. So that would be 12 feet. And then we're multiplying it by the height, which in this case is 18 feet. Right, and then we can do that quick little bit of math of 12 times 18 and get a value of 216 feet squared. So then the total area is just the sum of those two things, right? So the total area of hardwood that's needed, or the total area of the composite shape, is the area of 1 plus the area 2, the 144, plus the 216. And that gives us a value of 360 square feet to be covered in hardwood. Okay, so that one was relatively straightforward in the sense that we didn't actually have to go and calculate any of the other missing side lengths, right? I mean, we never used that 24, but we would have if we had done it this way, right? But we didn't have to figure that stuff out. What I mean by that is, let's say that this piece was missing, right? And we did want to figure out this area here. We would have to do just a little bit of logical reasoning to figure out what that value is, because we know that this entire length here is 18, and that 18 is composed of two sections, and you know that this section matches with this one over here, which is 12, right? So the difference between 18 and 12 is 6, meaning that if this is 6 feet, then so is this, right? So even if all the dimensions aren't given to you directly, you can still find them in some way, okay? All right. So again, this was your answer. Like I said, there were 2 ways, so I did it this way, right? And you see those, the 144 and the 216. Had you tried to do it the other way, again with the top and the bottom rectangle, you get 2 slightly different areas, right? This one would have been 72, and then this one would be 288, but then when you add them together, you still get 360, right? There would be a third way to do this, and that's through subtraction. It's one that people sometimes don't see as quickly, but could be done, right? You see that in this solution here, is thinking about it as one big shape with just this little bit cut out of it, right? So in that sense, you would use that full length of 18 and that full length of 24, calculate the area of what that huge rectangle would have been, right? So 18 by 24 would be 432, and then figure, well, what's area is missing here? And that little area here is a 6 by 12 rectangle, so you can calculate that as 72 and then subtract them, right? So it's maybe sometimes not as obvious, but it is an option. All right, so let's take a look at example 2. So in this one, right, we're talking about the keys of a basketball court, and the keys themselves are in the shape of a rectangle, and it also includes a free throw area, and each of the free throw areas are in the shape of a semicircle, so an exact half of a circle, and these areas can be painted so that they stand out from the rest of the court. Calculate the total area of the key and free throw area to the nearest tenth of a square meter. Okay, so we've got 2 different shapes again coming in on this one. All right, so we'll switch again. All right, so in this one, we have the following shape. Right, and we've been given that this length here is 5.6 meters. This value here is 3.6 meters. Okay, so again, what we're looking at is the area of this entire shape. So you can think of this as, okay, well, here's the first part. We'll talk about the rectangle, and then we'll deal with the semicircle afterwards, right? So we think about number 1. That's the area of a rectangle. So it's just base times height. So it'd be 3.6 meters times 5.6 meters. Okay, and we would multiply those. And we would get a value of 20.16 meters squared, right? There's just the key, right? Now if we look at the free throw area, the semicircle, remember that the area of a circle would have been pi times the radius squared. But we're not interested in just a circle, we're looking at half of a circle. So once we find that pi r squared, we need to divide it by 2. Okay? So the next thing, in order to be able to solve this one, is we need the radius of the circle. You notice that there's no value given in the circle part, but this dimension is the same. If this is 3.6 meters here, then across here is also 3.6 meters. But this is not the radius. This is going entirely across the circle, which would mean that that's the diameter. So the radius is going to be half of 3.6, right? So I can take my 3.6, divide it by 2, and that should give me 1.8. All right, so that's the value I'm using for my radius. So when I go to actually do my formula here, it's pi times the radius, which is 1.8 meters squared. Get that answer, and then divide that by 2, right, or cut it in half. So we can take that, remember, follow your exponent laws, take your 1.8 and square it first, then multiply that by pi, and then get a value. So like that full thing there gives you 10.1787602, which you're now going to divide by 2. So that area is 5.08938 meters squared, right? And again, what we're looking for is the sum of these 2 things, right? So at this point, we would then add those 2 areas together. So our total area is going to be that 20.16 meters squared from the rectangular key, and then adding the free throw area of the 5.08938 meters squared, and we get a value there of 25.249 square meters. And I think it wanted to the nearest tenth, so that's just one decimal place. So at the one decimal place, we look at the second, that's a 4, so that means this would stay at a 2. Okay, I know the argument comes up of, yeah, but that's a 9, which would bump that to a 5, which would then bump that to a 3, but that's not how we do rounding. When we do rounding, we just look at the next point, right? Because really, if it's like 49, well, 49 rounds down. Okay, just because the 9 would round the other one up, not how it works. Okay, so there's our area, the 25.2 meters squared. Okay, and again, you see that same math that's happened there. All right, so we have a third example to look at. We'll be looking at 4 altogether in this lesson. So in this one, Ray was hired to stain a wooden deck. He needs to estimate the cost of the stain needed. Right, so what you have there in the image, that's what the deck looks like. Okay, and the first thing we need to do is obviously calculate the area of that deck. Okay, so again, what we're going to do with that is cut it up into some pieces so that we can calculate the area in bits and then add them all together. Okay, so again, here's the shape that we're dealing with. Okay, where we were told that this little section here was 12 feet, this was 6 1/2 feet, this length was 22 feet, and this is 12 1/2 feet. Okay, so again, there's different ways of how you want to cut up this shape. Just because you wouldn't do it the way I do it in a marking guide, or you don't do it in the way that I do it in this example, doesn't matter. If you're getting the same answers, right, and you're showing all of your work. Right? So for me, when I look at this, I think about taking that value and cutting it straight down, right? And that creates a rectangle in here, shape number 1, right? And then I think about seeing where this kind of slanted piece ends and cutting that straight over, right? And then that gives me another rectangle here, shape number 2, and a triangle here to deal with the shape number 3, okay? So we look at shape number 1, that's a rectangle, so the area would just be length times width or base times height, which in this case would be 12 feet times the 12 1/2 or 12.5 feet. Okay, so 12 times the 12.5, so that area is exactly 150 square feet, okay? I look at shape number 2. Again, that's a rectangle. I have the height of the rectangle here at 6 1/2 feet. What I do need is the base, right? That 22 feet is the whole thing, so I don't have it exactly, but I can figure it out with a little bit of logical reasoning, because if this whole thing was 22 and this bit in here was 12, if I take 22 and I subtract 12, then just this in here is 6 feet, or 10 feet, sorry. Right, because 22 minus 12 would be 10. So for area number 2, again, it's a rectangle where the base is now 10 feet, and the height is 6 1/2 feet, or 6.5 feet. And when you do that, you get an answer of 65 feet squared. Okay. Now, that just leaves number 3, right, shape number 3, which is a triangle. So I'm just going to kind of do that over here. So the area of our triangle, remember, is base times height and then divided by 2. So the base of the triangle, right here would be our right angle, the base of the triangle would be along here, which we just determined was 10 feet. So the base would be 10 feet, multiplied by the height. And again, we would need to figure that out, right? Because the entire height of the shape is 12 1/2 feet. This little section here was the 6 1/2 feet. So to get this part, we would just subtract, right? 12 1/2 minus the 6 1/2 leaves a nice even 6 feet for this height here. Okay, so the height of that triangle would be 6 feet, and then we would divide it by 2. Right? So 10 times 6 would be 60, and then 60 divided by 2, so it would be 30 square feet for shape number 3. Right? So you've got 30, 150, and 65. Right? So your total area is just adding those together. Right? So it's the 150 plus the 65 plus the 30. And that's where we get a total area of 245 square feet is the area of the deck. Okay, so we'll keep that in mind as we look at part B of this question. So part B of the question is saying that a 3.78 liter can of wood stain covers about 300 square feet. How many cans of stain does Ray need to cover the deck with 1 coat of stain? And no real work is required there for that one because we just need to think about it. 1 can covers 300 square feet. What we have is 245 square feet. That's less than 300, so 1 can is enough. Okay, so again, those answers are there. And again, it does say there in B, right? So since 245 is less than 300, then we just need the 1 can. Okay, okay, on to our final example. So in this one, a patio made of concrete patio stones surrounds a circular pool. Helen wants to paint the concrete with a sealant to protect it. 1 can of sealant covers 175 square feet. What is the area of the patio to the nearest square foot, and how many cans of sealant does she need? Okay, so let's do this last example together. All right, so what you've got is, okay, so this is number 4. So we've got a rectangular thing with our pool. Okay, so we know that this is 32 feet here. We know that this is 25 feet here, and we've been given that the diameter of the pool here is 21 feet. So we're interested in the area of just the patio. Right, so this would be this area here. Okay. Now, this is a particular question where we would have to use subtraction. Okay, because if we were trying to split this up into shapes, it's a little bit trickier, because if I tried to cut this here and this here, one, I don't have any information about how far away that is from the edge, so I'm not sure what that's going to be. Then we've still got kind of curves that are happening here. So the best way to do this one is to actually calculate the area of the entire rectangle and then subtract the area of the pool in the middle, right? And that'll give us that shaded area there. Okay, so the first thing we do is we calculate the area of the rectangle, which would be 25 by 32. Right, so we'll do that. So that gives us 800 square feet on that one. Okay, now we would need to calculate the area of the pool. The pool, we're told, is circular, so its area would be pi r squared. Right, so pi times the radius squared. That value of 21 feet is the diameter, so I need to cut that in half to get the radius, which would be there. So 21 divided by 2 is going to be 10.5. Right, so my area of the pool is going to be pi times 10.5 feet squared. Right, again, so you'll take your 10.5 and you'll square it first. Then you'll multiply that by pi, and you get a value there of the area of 346.36 feet squared. Right, so the area of the concrete is the difference between those. So it's the 800 square feet minus the 346.36. And in doing that, we get 453.64 square feet. Okay, so there's the area of the patio that needs to be covered, that 453.64 square feet. All right, and now what we're looking at is that, well, the 1 can of sealant is 175 square feet. So what we would do is we'd take that 453 and divide it by 175. And that would give us a value of 2.59. We'll go back to the board now in a second. Okay, so again, what we're using there is we're using that area that we calculated. So the area was the 453.64 square feet. Now it did say to round that to the nearest square foot, so we would round that to 454 feet squared, okay? And then we would take that value to figure out the number of cans. We divide it by how much one can covers, which is 175 square feet in each can. And when we do that division, we get a value of like 2.59. And in that case, we would have to go and buy a third can. Okay, so 3 cans of sealant are needed. Okay, because you do need more than 2, so you would have to go out and buy the third. Okay, and that's what we're doing there. Okay, so again, your answer is here. So same idea there. And then what I've got for you to work on is, again, a worksheet of practice questions so that you can brush up on your skills, right? So practice these types of similar questions of finding the area of composite shapes. Okay, and then again, the solutions are there provided just like last time, so that you can check your work and make sure you're on the right track. But again, if you're not getting the right answers or you're not sure what to do or it's just not enough, please just get in touch and we can set something up so I can help you a little bit more. Okay, what will be coming out next as well is just a 1-question check-in on this composite shapes. All right, so I'll be providing you with, I think, 9 different shapes, and you'll just have to choose one based on like your student number or something, and that's the one you'll submit. Okay, and I'll come up with the instructions for that, but that'll be in a couple days, right? So I'll kind of give you this video to work through the practice problems, go through the solutions, make sure you're okay, and then I'll be posting the 1-question check-in for you to complete based on most likely, again, like your student number, okay? And then that's that.